All right, now I got one more question to throw at you here. How do we know that's the only answer? Is it true that all math equations have a single answer? Well, you'll eventually see that's not true. There are equations with 2 answers, 3 answers, infinitely many answers, depending on the situation. So, but linear equations have 1 answer. Now, where's that word, what's that word linear have to do with this? Linear, of course, comes from the root word line. And you can recognize in algebra a linear equation when the exponents of the variable is always 1. And there's nothing like x squared or x cubed. There are not variables multiplying each other like x times y. That doesn't happen. You don't have a variable in the denominator like 1 divided by x. You don't have that. That's you don't have anything like square roots or logarithms or sine or cosine. So this is a real typical linear equation. And it turns out you can show that linear equations really do represent lines. Now one of the miracles of algebra that was uncovered around the 1600s, about 1642, by René Descartes, was that algebra has a geometric side to it, just as geometry also has an algebraic side. And Descartes was the one who found a way to blend these together. And so we have a geometry way of looking at this problem. And so this is a little bit extra for you, but I like to show this early in the course, just to impress upon you that there is a geometry behind a lot of what we do in algebra. And as you move up in math, if you take more and more math, you'll find that this link between geometry and algebra really does a great deal to inform you on how things work in algebra. All right, so I'll quit rambling here, and let me just quickly show you what I'm talking about. And then this will hopefully persuade you that there's only 1 answer to this equation. All right, so if we combine terms here, we get, like we did before, we had minus 4x minus 7. And over here I've got x minus 17. So that's simplifying both sides. All right, if I look at this left side as equation y equals minus 4x minus 7, and the right side as equation y equals x minus 17. You may recall from your first algebra course that these are equations of lines that you can graph. And what happens when you graph these, and I'm just going to have to really guesstimate it here. I'm not going to try to make a really super graph, but let's see. This graph would be, let's see, it's going to go like this. Well, that's minus 17, this is 17. And just take my word for it right now that this is what's happening. This graph comes down about like so. So really, the left side of this equation is represented by this steeply declining graph. The right side of the equation is represented by this diagonal graph here. And guess what? They meet down here at, where would they meet? If I know what I'm doing, I think it's at 2 comma negative 15. But the main point is that if you come up here, that's 2 on the x-axis. And so here's a little miracle that was behind the scenes of solving this equation. It looks like a rather boring type of equation, but what happened was that we managed to find where 2 lines intersected on a graph, and the x value of their intersection was 2. X equals to 2, which was the solution to this problem. So I always thought that perspective is pretty interesting. I hope you found it neat also. But anyway, why does it have one answer then? Okay, well, straight lines can only intersect in one place, can't they? As long as they're not parallel or stacked on top of each other. If they run in different directions, they can only cross in one place. So we've just demonstrated that, in a sense, that linear equations can only have one answer at most, and or at least one non-trivial answer. I'll elaborate on that in a minute. But anyway, by and large, they're all like this. They have one answer. So, okay, well, I have two other quick examples to show you to round out this particular topic. Okay, here's a really interesting example, at least to me it is. I didn't want to leave the wrong impression. Linear equations can also have no solutions. And this is the simplest equation I can think of that has no answer to it. Solve x equals x plus 1. Alright, now there's about one thing to try here that makes sense, and that's to subtract x from both sides. And when we do so, what happens? X's cancel on the left, 0. On the right, x's cancel, leaving 1. 0 equals 1. Now what? Well, that's certainly a problem. So, but it's impossible, and so I would write no solution. So, you need a conclusion. Don't just don't leave your reader or the person grading your papers just hanging with 0 equals 1. Let us know what you decide that means, and that means that there is no answer to that equation. So now how can that be? How can there be an equation with no answer to it? And well, it's a very simple explanation by looking at the geometry of it. And so if we looked at the left side as the line y equals to x, and the right side as the line y equals x plus 1, then when you graph it, and again I realize that we're not going to do graphing until the next chapter, but it's something I think probably most of you have seen somewhere in the past. So just take my word for the graphing for right now. Y equals to x is this line here going through the origin, and y equals x plus 1 is this line going through y-intercept at 1. Okay, well, that's supposed to be straight. It's a little wobbly. But the idea is that they're parallel. They're parallel. So if you learned about slope in your previous algebra, each of these lines has the same slope of 1. That means they're going in the same direction. They're parallel. And what do we know about parallel lines? They do not intersect. They do not intersect. And so without that intersection, there's no solution to the algebra problem. In other words, the algebra confirms that it's impossible to intersect these lines, and vice versa. So there, I think it's, the geometry is telling us something about this oddity, this strange situation. All right, now we'll run into a couple of these along the way in this course, but they're pretty rare. Generally, these problems are not too interesting, but once you see the first one, but it's worth a mention. Okay, I have a third type of equation to show you here. So let me erase the board and put that up.